Today we are talking about inequalities. What is an inequality and what does that mean? An inequality says that two values are not equals. A is not equal to B. Sometimes you would see inequalities, not equation, meaning that we do not know exactly what an expression is equal to. Therefore, you don't have equal sign. Instead, you use another signs such as greater or smaller that indicates the greater value of an expression or smaller value of that. The signs that we use in inequalities are, this sign means greater than. For instance, we say x plus 3 is greater than 12. The other sign we use is less than. It means, let's say we have 7x is less than 21. The other sign is less than or equal to. For instance, 2x plus 3 is less than or equal to 7. Or greater than or equal to 5 is greater or equal to x minus 1. So these are the signs we use instead of equal sign in inequalities. Question: how to solve an inequality? How to solve inequalities? Just like equations, the solution to an inequality is a value that makes the statement true. You can solve inequalities in the same way you solve equation, that is to have x or any unknown variable like z, b, w, or any of your choice on its own on the left side of inequalities. Let's say we have x minus 5 greater than 5. Like equation, the first thing we do is to take care of minus 5. So we'll have x on its own on the left side of the inequality. So we'll have x minus 5 plus 5 greater than 5. And you know that whatever we do to the one side of the equation or inequality, we do to the other side as well. So we'll have x 5 plus 5. Then we'll have x greater than 10. Now the question is, what does it mean? What x greater than 10 means? It means that you have plenty of options to solve for x. It could be any number starting from minus infinity to a number below 10. It could be any number. Let's say, let's draw it on a number line. This is our number line. 0, 5, 10, 15, minus 5, minus 10, minus 15. That's minus and positive infinity of both sides. So x greater than 10 means you have plenty of options for x. X could be any number that is greater than 10. No number below 10 can sit for x, but any number greater than 10 could be x. and make that the statement true. And we can test it. Let's say we pick a number 11, x minus 5 greater than 5. We put 11 instead of x, so we'll have 11 minus 5 greater than 5. It will be 6 greater than 5. Let's choose another one like 15, x minus 5 greater than 5. Then we'll put 15 instead of x minus 5 greater than 5. And we'll have 10 greater than 5. So any number greater than 10 can make this statement true. So we can add or subtract any number to an inequality to both sides and the statement remains true. But sometimes the operation we do changes the direction of inequality, and in that case we need to swap the sign in order to have the statement true. Let's clear the board first. There are two situations that we need to swap the sign of inequalities when we are solving them. The first situation is when we are swapping the right side of inequalities with the left side. So swapping the left and right hand side of inequalities. Let's say we have 12 greater than 2y plus 3. Before trying to solve it, we need to swap two sides of inequalities. And in that case, the sign has to swap too. So we take the 2y plus 3 to the other side. So we'll have 2y plus 3 and 12. Let me change this color. 12 will go to the other side, so we'll have 12 in this side, but the sign will swap too, so we'll have 2y plus 3 is less than 12. Now this is the first situation that we need to swap the sign. Let me put another example here. Let's say we have 75 greater than 15x minus 5. Again, we swap the sign. We'll have 15x minus 5 is less than 75. So in this case, the statement is true. Here, in the first form, we have 75 greater than 15x minus 5. In this situation, again, in the second form, we have 15x minus 5 less than 75. So this is the first situation that we need to swap the sign. There is the second situation that we need to flip the sign, and that is when we multiply or divide inequality by a negative number. So when multiplying or dividing inequality by negative numbers. Let's say we have minus 2y less than minus 6. The first step in solving this inequality is to divide it by minus 2 in order to have y on its own on the left side. So we divide both sides by -2. Then we'll have y, we swap the sign, is greater than +3. Let's say we have -5x less than 15. We divide both sides by -5, and then we'll have x is greater than -3. So whenever we need to multiply or divide the inequality by a negative number, we swap the sign. Now, you might ask that why we need to flip the sign when dividing or multiplying by a negative number. Let's see what will happen if we don't swap the sign. Let me clear the board first. Let's consider this number line. We have 0, 1, 2, 3, 5, 6. So we'll have positive infinity this side. Now, by looking at this number line, you can see that as we move toward right, the numbers are increasing. But as we move toward left, the numbers are decreasing. It means 4 is less than 5, 2 is less than 3, -2 is less than -1, or -5 is less than -4. So we know that as numbers move toward right, they get larger and bigger, and as they move toward left, they get smaller and smaller. We know that 1 is less than 2, or 3 is less than 4. Let's imagine this is a book, right? This is a book, and this is 2 books. 1 book is less than 2 books, right? Let's multiply them by -2. So we'll have -2 less than -4. -2 is here, and -4 is here. Which one is bigger? -2 is bigger than -4. Therefore, this statement is not true a statement. While these two are a true statement. Same as with 3 less than 4, if we multiply it by a negative number, for instance by -2 multiplied by -2, you'll have -6 less than -8. Which one is bigger? -6 is bigger than -8. So this is also not a true statement. While this one is a true statement. So the reason we swap the sign when we multiply or divide by a negative number is because the result is smaller. So in order to have this statement true, we need to swap the sign. Now let's work with some examples. -4x greater than 12. Again, our goal is to isolate x on the left side of the equation. Right now we are multiplying x by -4, so we can divide each side by -4. Since we are dividing the number by a negative number, we need to swap the sign. So x is greater or equal to minus 3. Let's see what it looks like on the number line. When we are locating a number on the number line, we use a circle to show it. But this circle can be empty circle or a closed circle. It depends. If it's greater or smaller than a number, then we use empty circle. But when it is greater than or equal or smaller than or equal, then we use a closed circle. That is because x could equal to minus 3. So all the numbers that are greater than or equal to minus 3 can make this statement true. Since this is greater than or equal to minus 3, our arrow is going toward the right. So all the numbers that are greater than or equal to minus 3 could make this statement a true statement. We can test our solution. We can choose any value greater than or equal to minus 3 to test our solution. Let's choose minus 2. Now we can rewrite our inequality. Minus 4x less than 12. We substitute minus 2 for x, and minus 4 times minus 2 is less than or equal to 12. Negative 4 times negative 2 is positive 8, less than 12. So this is a true statement. Let's work on a 2 steps inequality. Let's say minus 2x minus 1 is greater than or equal to 9. Again, our goal is to isolate x on the left side, so we write minus 2x minus 1 plus 1 greater than or equal to 9 plus 1. Then these two cancel out, and we'll have minus 2x greater than or equal to 10. Then right now it's multiplication, so we divide each side by minus 2. X is smaller than or equal to minus 5. So we are done. We solved our inequality. Now we know how to solve inequalities. Let's do some practice at home. 4x plus 6 less than or equal to 3x minus 8. 3x minus 7 less than 10x plus 7. 5x minus 3 less than 12. 30y less than or equal 10. N over 25 less than or equal to 5. Minus 5x is larger than 75. I'm going to solve one of these inequalities for you. 3x minus 7 less than 10x plus 7. So first thing we want to do is to have x in the left side of the equation and numbers to the other side, because our goal is to isolate x, right? So we write 3x. 10x is a positive number, When we move it to the left side, the sign will change and it will be negative. So 3x minus 10x minus 7 is less than 7. Now, we have two things to do here. First, to combine the like signs, and then to isolate the x. To do that, first thing, we get rid of minus 7. So 3x minus 10x minus 7 plus 7 and is less than 7, and we add plus 7 to other side and plus 7. So we'll have 3x minus 10x. These two cancel out and we'll have 14. Now we can combine these two numbers and we'll have minus 7x. Positive 3x minus 10x will have minus 7x less than 14. Now, right now, this x is multiplied by minus 7, so we divide it by minus 7. We divide both sides by minus 7. So, since we are dividing it by a negative number, the sign needs to be swapped. So we'll have x is greater than minus 2. And we are done. Minus 3 plus x less than 12. M over minus 3 is less than 9. These are, as you know, one-step inequalities. And let's move on to multi-step inequalities. Let's say we have 2x plus 7 less than x minus 4. 5 times x plus 3 minus 2x greater than x over 2. 9x minus 8 is less than or equal to 2x plus minus 4. Minus 5 plus 4x is 2x minus 1. X over 5 minus 5 less than or equal to minus 4. I think we are done with inequalities for now.